Hi there. I thought I'd take a few minutes to just go through the Carbon Cycle Laboratory, for which we are using the simulation Habitable Planet. You'll click on it here, and then the data table that we'll be using to record our observations and answer a few kind of overview questions can be found here. You can download it or simply view it there. The Habitable Planet simulation, you open the same simulator for all of the different lessons. And we've got actually 3 different lessons. So there's 3 different pages of data tables, but you're actually running 2 different simulations for each one. So I thought I'd walk you through that. It's kind of confusing in the instructions. Start with the overview here, and it's going to talk a little bit about the carbon cycle and a little bit about how this data is found. So this data is actually real data, and it's used to look at some of the climate change prediction or carbon emission predictions in real life. So we'll be using this data to run the simulation. And so you open the simulation here, and let's take a look. The simulation default, we're going to start off here in carbon cycle, so it'll automatically go to here, but you're using the same simulation for all 3 labs. You're just changing some of these parameters. So for the carbon cycle for data table number 1, so it's lesson 1, step 1, you're just starting off looking at the amount of carbon in different sinks, so from the atmosphere to plants to soil to ocean, and the data we're collecting is in gigatons. So the atmosphere right now, 720 gigatons. Terrestrial plants are storing about 700 gigatons. Soil about 1800 gigatons. So these are sinks, right? This is where carbon is being stored, being held at the moment. And you're going to look at it over time. So we can run per decade. So my first line of data is just the initial settings, and then I'm going to click here to run a decade and write down. I'm seeing an increase based on our current. These are 2010, I think, predictions or data to about 2% increase change in fossil fuel use, and how that affects the amount in terrestrial plants and soil and ocean. So I'm seeing an increase here in the atmosphere as well as terrestrial plants. I'm not really seeing it in soil. But I'm writing that data down then in line 2 under 2020. Let's go forward another 10 years, 2030. So I'm actually just recording data for 2010, 2060, and 2110. The second step, so lesson 1, step 2, let's go back to our instructions here on the left-hand side. And what it's going to have me look at is actually where this carbon is going if I am increasing the amount of carbon in our cycle by taking it from the bottom of the fossil fuels deep within the earth and bringing them up and burning them and having that be released in the atmosphere. So the same simulation, but instead right now what I'm looking at, I'm going to reset it. I'm going to look every 10 years. I'm writing down this data for step 2, and I'm actually going to be looking at the emissions themselves. So if you look, when I first start in 2010, there's no number. That's just a default setting, so just 0 or not NA, non-applicable. But then my gaseous carbon, if I look, right, I've got parts per million, 391 parts per million in the atmosphere. But if I scroll down here in my soil, I'm seeing increases. Can I get rid of, let me move myself here. Let's see if I can move myself. I'm in the way. Hopefully you can see this, but if you look here where it says soil, it's got the 1800 again, but it's got plus 200. So in that decade, I saw an increase, right, of 200 gigatons. Same with the ocean. I'm not seeing actually any increase, but let's run decade by decade. So as I go up a decade, right, I'm just coming down here, I'm seeing increases. And can you see this, or am I in the way? I'm in the way. There we go. I'm seeing increases, even in the deep ocean, right? So I'm writing down as I go through each decade in each of these sinks, right, these increases. So here you're gonna have to do the math yourself. Your smokestack data is here. And again, each one of these blocks is 25 gigatons. So that is lesson 1. Let's take a look at lesson 2. I'm in the way again. So in lesson 2, we're looking at the fact that we are basing that carbon data on current emission levels of about 2%. Actually, current emissions are a little higher than 2%. But what happens if scientists were able to discover some kind of clean, non-fossil fuel, non-CO2 emitting fuel source? So we're going to actually, it's very unrealistic, but say that happens. So we're going to go back to the simulation, and instead of having the carbon increase 2% every year, we're actually going to set it to none. So this is as if no new additional CO2 was contributed to the atmosphere. So that data is going to be recorded in data table number 2. That's step 1, right? So you're recording, I think you've got 3 different decades here you're writing down the data from. So unlikely, but let's see what would happen. How long would it take the atmosphere or the soil? What kind of equilibrium would be reached at that point? Okay, so you're going to discover that in step 1, even with no further input from humans, right? There's still a little more carbon dioxide in the atmosphere. It's going to take the Earth quite a while to work that out. So instead, we're going to see if we can figure out something different. We're going to look and see if we can keep our parts per million of CO2 in the atmosphere to below 550 parts per million in 2100. And that's a goal, right? That's a goal that a lot of nations are kind of debating on trying to keep those, a threshold of emissions. So if that were the case, if we try to keep it right underneath these levels, which they've been a lot of reasons why this goal was set, what kind of percentage of carbon emissions would we need to curb? So up here, I'm going to curb my emissions. And I don't know what percentage this is going to be. That's kind of what I'm solving for here. So I'm going to play around with my percentages here to see what I can do to keep. Here's my, let's see, we want to keep it by 2100. So here's my 2100 right here. 2100, sorry, right here. And here is that threshold, that 500 parts per million. Can you see that over here? Let me see. 500 parts per million. So let's just run it right now. I don't know. Let's say 1.4%. What happens? We're gonna run it up to 2100. Oh, crikey, that didn't work, right? So reset, and what we're gonna do, we're gonna run 3 different attempts with different percentages, and you're gonna see if you can figure out the percentage of emissions. Let's say, wow, 0.5. That would be a great goal. If that can keep it under this this threshold of 500. So if I try that. Right, so I'm basically, trying to get to 2100 without going over 550 parts per million. So that's part number, step 2 of lesson 2. So the last one, lesson 3, is the feedback effects one. And we're going to do 2 different labs in 2 different simulations using the simulator for this one. In step 1, we're going to look at how trees, as we've discussed, are a carbon sink, meaning they absorb CO2 through what process, right? And then that CO2 is stored in the trees. But what happens if we cut down the trees for resources? How does that affect carbon levels? So for this lab, here's your feedback effects. You're going to be looking, you're going to change the net deforestation rate and observe how that impacts carbon. So you're going to set the deforestation rate to 1.6 gigatons. Remember, when you cut down trees, you're actually releasing that carbon, right, by burning them or processing them, or the use of that as a sink into the atmosphere. So if I change this to 1.6, right, gigatons, that releases that carbon back into the system, into the cycle. So for lesson number 3, data table 1, you're looking at I don't know, 4 different decades, and the effect with that deforestation rate on the soil and the terrestrial plant levels. So how does that impact those levels? So then the last one for this, lesson number 3, step number 2 right here, is you're going to find possible scenarios that are related to a change in the carbon cycle. For example, in this case, we're looking at the feedback effects of having the tundra melt because we've seen, the relationship between temperature and greenhouse effect. So in this lab up here, you're going to feedback effects, and you're actually going to go ahead and melt the tundra. Oh no. And so when this happens, right, we're assuming for this last lab that the melting of the tundra is inevitable. And we're going to run this simulation at a 2% increase of fossil fuel consumption. And we're going to record that data here. We're going to look again if we melt the tundra half as fast. So 1/6 of it melting versus 1/12 of it melting over the same period of time, over 100 years. So you're going to run this simulation from 2010 to 2110. And you're going to record that data in lesson 3, data table 3 here, using the parameters given here. So again, just kind of running this, and we'll look at the impacts that that will have. Email me if you have any further questions. Otherwise, yeah, hopefully this is able to show you how carbon cycles through our Earth, how atmospheric carbon that's released from fossil fuels ends up in different places throughout our world.